Alright, welcome back to another exciting day of Algebra 2. Today we are going to look at linear regressions and residual plots. You will need your calculator for this, so if you need to pause and go grab that and come back, please do so now. But we are going to be looking at sets of data that can be represented by a linear function and how we can best approximate that when the data isn't perfectly linear. So for this first example, we've got the weight of babies modeled by a linear function for the first 4 months after birth. So we've got these values where W of X, or our Y values, are the weight in kilograms, and our X values are the age in months since the birth of the baby. So if I want to determine the equation of the regression line, I am going to take my calculator, and the first button I will hit is Stat, and enter for edit. Now your lists might already have some numbers in there. If that's the case, just hover over them and press the delete button. But in list 1, you want to put your X values. And when you're ready to go down to the next row, you can just hit enter. And then over in list 2, we're going to put our Y values. Okay, once you have done that, you're going to hit stat again, this time arrowing over to calc. And that fourth option there, linear regression, is what we want. So you can either arrow down or just press the number 4. Make sure that the X list has your L1, the Y list has your L2, because that's where we put those values. Hit enter 5 times, and it will give you, remember, our y equals mx plus b equation. So here is our slope, 0.8, and our y-intercept, 3.34. So I can put both of those values into my regression line. Again, linear approximation, linear line. So what is the slope, and what does that mean? Remember, slope is your change in y over your change in x. So if it's a positive 0.8, first of all, it being positive means I'm increasing. And the change in y is representing the change in the weight of the baby in kilograms, and the change in x is representing the change in time in months. So it means I am increasing baby weight by 0.8 kilograms each month. So the next question that says, what is the dependent variable axis-intercept? Well, if you think about independent and dependent variables, the y is your dependent variable. So what this is asking for in a very long-winded way is, what is your y-intercept and what does it mean? Well, remember, your y-intercept is when x equals 0, so I can see that on my table here, or if I plug 0 in for x, I could find it with my regression line, and I would get 2 different values, but either way they would be representing the same information, which is the weight of the baby at 0 months or birth. So with all that in mind, let's use our model to predict the weight of the baby at 2.5 months. So that is when x equals 2.5, and I'm just going to plug that into my function here. 0.8 times 2.5 plus 3.34. I'm going to do all my math. And I get 5.34 kilograms is my predicted weight. Okay, just another example to get you used to all those calculator buttons and interpreting the meanings. Now we've got the number of reported crime cases in some county in New York State is in this table, where X is the number of years since 1998 and Y is the number of new cases. So I'm going to go back to my stat in my lists, and I'm going to enter my new values. They go up to 5 now on my X's. And then in list 2, I'm going to put my new Y values. And then I'm going to do the same steps as before. Stat, calc, linear regression, enter 5 times. And this one's not as pretty of numbers, so we're just going to round to 3 decimal places. And I'm going to put it down here where it wanted my answer. So that's negative 17.086x plus 708.048. So what does our slope mean this time? Well, it being negative means we're decreasing. Change in y over change in x. The change in y is the change in the number of cases reported, and x is the change in years. So that would mean, again, because it's negative, that the number of cases is decreasing by approximately, because it's not a whole number there, approximately 17 cases per year. So what does, again, the dependent variable axis-intercept, that just means your y-intercept. What does it mean? Well, when x is 0, whatever the y is, that's saying when x is 0, time is 0. If it's years since 1998, that means we're still in 1998. So that is going to be the number of cases that were reported in 1998. And then lastly, let's use that function to predict the number of cases for 2008. Well, that is 10 years after 1998. So negative 17.086 times 10 plus 708.048. And because we're talking about cases reported to the police, this is going to be making the most sense to round to a whole number, and that's going to be about 537 cases. Okay, so remember, we had our predicted values and our actual values, and they weren't always the same. So the difference between those two is called a residual. Your residual is your actual y value minus your predicted y value. So if we take it back to that baby weight problem, this was the regression line I got. And when we did the weight of the baby at 2.5 months, you might recall that we got 5.34 kilograms. Well, if the actual weight of the baby was 5.5 kilograms, my residual would be that 5.5 minus 5.34. And the residual is the difference, the remaining 0.16. That's our residual, and because it's positive, that tells me that my estimation was an underestimate. Another example, calculating residuals. This math teacher is plotting students' grades on a quiz against the number of hours that they studied. So the points that are all over the place, that would be like our initial scatter plot or our data table. And then she used a regression to create a line of best fit. And what we are wanting to compare per this problem is the data point that corresponds to 1.5 hours of studying and a score of 60.5 points. So I'm going to look on my graph, and here I have this scatter plot point at 1.5, and it told me in the paragraph above that the actual score there was 60.5 points. So that is my actual score. But if I look at my line of best fit, the point here, predicted value for 1.5 is 65. So to calculate my residual, I'm going to take that actual value, 60.5, and subtract our predicted value, 65, and I get negative 4.5. Now this time it was negative, so that tells me that I had an overestimation. Okay, so now we are going to use what we know to graph a residual plot. So here we've got Jasmine keeping track of the number of coffee drinks she purchased in a week, and the amount of money she spent on it. So she's already done the linear regression for us, and here is the equation of the line. So we want to construct a residual plot. Well, remember, residuals are actual minus predicted. So we already have our number of coffee drinks and the actual amount of money she spent, but what I need now is the predicted cost. So again, you can use your calculator as a shortcut for this. In your y equals, type in that regression equation it gives you. And you want to make sure your table set has the independent variable on ask. Go to your table and you can type in those x values for the number of coffee drinks, and it will calculate the predicted values for you. Now, if you don't think you can remember those calculator steps, you are welcome to do this by hand. I trust that you could plug into a linear equation 10 times, but this is just a little bit of a time saver. Okay. So I've got my 10 predicted values. Now I need to calculate my residuals. Remember, that is actual minus predicted. So again, you could do that subtraction 10 times across here, or another little shortcut, go back to your stat lists, and in list 1, put your actual values. And in list 2, put your predicted values. Okay, once you have your actual and predicted values, you're going to arrow over to list 3. and arrow up so that L3 is highlighted and press enter. And I want it to calculate list 1 minus list 2, my actual minus predicted. So I'm going to go to this list button here, list 1 minus list 2, and it will calculate my residuals for me. Again, I trust that you could do subtraction 10 times if you would rather not mess with these buttons, but that is totally your call. Okay, so to make my residual plot, I'm going to take the first column of our table here. That is going to be my X values. And our final table here, our residuals, that is going to be our Y values. So we are going to match these X's and Y's 10 times to get just 10 points on our graph, and they will be kind of like a scatter plot. And we're just going to eyeball them because they are not perfect numbers. And there is our scatter plot, our 10 points. So what is the point of a residual plot? What does it tell me? Well, a residual plot tells me if we used an appropriate model or not for a set of data. So if you used a linear regression and plotted your residual, you would want there to be no pattern when it comes to your residuals. If we see a pattern, that means we did not use the right function. We should have used quadratic, exponential, or something else. So if we look at this first example here, they tried 3 different ways and got 3 different residual plots. So if I look at the linear residual, this has kind of a U shape and looks kind of parabolic. I could draw a line connecting them. They look like they flow together. Therefore, this was not an appropriate model. Similarly to the quadratic one, this is kind of like an oscillating function of some kind. It looks like it has a pattern or even like a double curve here. So also not the right model. But if I look at the exponential one on the right, it looks kind of just like a splattering, like I just threw points on the board and there's no rhyme or reason between them. That means that this was the best appropriate model for that data set. So with that in mind, we're just going to end off with 2 AP-style multiple choice questions. So if I have a linear regression that was used to model a data set, and this is our residual plot, I notice immediately that this data has a parabolic shape. Therefore, I know that this was not going to be an appropriate model. So I can eliminate A and B because we know it's not appropriate, and now I just have to determine what the correct reasoning is. Is it because the residuals do not show a linear pattern, or is it because the residuals show a quadratic pattern? Well, we don't even want a linear pattern. We want no pattern at all. So D is the correct answer. It looks like a parabola, so it's not an appropriate model. And then last but not least, we've got this exponential regression was used, and here is our residual plot. And it looks like a smattering of points all over the place that is totally random, so we know it is appropriate, so I can eliminate A and B again. And now we just have to match the correct answer. Is it appropriate because the residuals show no pattern, or is it appropriate because the residuals show a pattern? Well, we just said it was random looking, no pattern, so C is your correct answer there. And that wraps up our first little introduction into regressions and residuals.